the slide on how to open up a socket and do an inter-process communication IPC using the tickle commands. These are some of the commands on the IOs and processes essentially. So using these commands, actually you can run external command using tickle. So exec or exec is one of the commands that can start a process. We defined the process and programs in the very first lecture, if you remember, and then the exec can also use ampersand. You know what this means. This is basically to run the process in the background. So we can actually run the process in the background or in the foreground, however it is. So to use that, here is a typical example. We set the favorite editor command to Emacs, and then we just say exec $favorite editor and then with an ampersand to run it in the background. And then yeah, for the file names, actually, like you can use the glob command to expand the files instead of just giving the file name expansion itself. So here is an eval command of exec, and the exec is essentially like it's a ls of glob star.c. And you notice a couple of things. One is like this command is actually enclosed in the quotes, meaning during the interpreter time, this itself, this everything will be this command, like for example the glob command will be executed and it will be expanded. So this is the command substitution example, and the star.c will be expanded based on the glob command, and so basically it will become ls the entire list everything with .c, and so and then exec will actually print out that values. And then you can also open pipes using the open command. For example, if you want to pipe the command to grep for the word foo in the bar.tickle with a read only option, we can actually set this thing as an open with an open command, and then the open command will pipe that into the app. And then here basically like this only just until the end of the file basically, or end of the file basically read the $f. So this command essentially searches for the word foo in bar.tickle. So so that's the way to look at it basically. So this is one other command. Then there are some runtime informational facilities basically. For example, during the command line arguments, argc is the count and argv0 is the interpreter name, and argv is the list of arguments. We will look at this in more details as to how to set the various interpreters. So this is one of the things basically. So if we query the argc, that gives you the command, and then the first argv is actually the interpreter name, and then the remaining is the list of arguments. So and then you can also query for the tickle tk version. The commands are the tickle version and tk version, and then it can print out numbers like 7.5, 4.1 respectively. Then there are platform specific information that you can query. So one such thing is basically the tk platform array that prints out a whole bunch of information. We can also query the OS information, the machine, platform, and OS. Actually this prints out these various things, and in that order. So it is the OS version, what kind of machine it is, what platform it is in, and then what is the OS itself. So so these are some of the other commands, and then there is also info command. And info command can have additional variables.
So info vars is one command, info globals is another one, info locals, and then info exists. These things can give you information about the various variables that you are using for the program. And then if you have defined the procedures and how you have defined the procedures, those you can get it through this info procs, info args, info default, info body, and info commits. Then there is also a rename command. This is, you can rename any command, even the built-in commands you can rename to another command. And also then because of this rename, you can actually replace any built-in command with your own commands. So you can use, like, for example, rm, I mean basically one of the commands for a different one. Then there is an auto loading feature in Tcl. When the command doesn't exist, usually an unknown is invoked, and then basically the auto loading actually loads Tcl procedures on demand from libraries. It uses the search path of the directories. Then we also have a load Tcl command. Essentially this is a long awaited standard interface for dynamic loading of Tcl commands from DLLs and .sos, etc. So if you have a compiled Tcl scripts, basically you can use load Tcl to load it at the runtime. Interp Tcl command. This is interp is another command basically, which is you can create multiple independent Tcl interpreters in a single process. So and then there are also like options along with it. The -safe option creates a safe Tcl interpreter. Then the version 7.6 and 4.2. Basically this is like the main improvements over the previous versions. One is the grid geometry manager has been revised, and then it is needed for spec-Tcl code generator or the GUI builder. There is also C API changes for the channel drivers. This will eliminate the Tcl file usage. And then as I mentioned, like here the GUI stands for the graphical user interface. And then there are a whole bunch of bug fixes that went into these releases. Even though it says like beta, I think like this is already released and you should be able to find these releases. And then we talked about some of the issues with Tcl. So for example, in this command, so some these ones we haven't covered much, but assume that this is some command. And then here is a command which has puts std out $label with quotes. And this quotes, once we specify this quotes, this may not work correctly because here the text label where we specify the $label and somewhere else we are specifying set label. This label can have multiple words. So when we say like standard out with multiple words, and since it is quotes, as you know, like I mean interpreter substitutes the variable. This is a variable substitution. So it can substitute into those multiple words. For example, if it is label is my name, then you have my space name. So now the puts command does not take those multiple words. It needs to take only one word. So to fix that, we can actually define it like this basically, where we define this as a list with the command so that it executes as a list, and then so each one is treated as a separate entity. So even if you have multiple words, those words will be combined and treated as a single word, so that when you say like puts standard out that particular word, like say my name, it produces the correct output. And then we went through this particular
particular program in a lot of details. So here is this program is mainly for sorting, and one thing quickly we notice is basically it has the arguments as args, and we know that that stands for variable length arguments. So in this case actually it is basically it takes in a set of files, and then basically it sorts the files essentially, or the lines in the files essentially to see which order it should be. So here we start the program by seeing like what is the number of arguments or number of files in the arguments. So essentially like we just do an L search of that arguments, and that gives you like how many files are there, and if it is greater than 0 then we start processing the files. So if it is greater than or equal to 0 then we say like set files, the range is the index -1 to the end. So we split that into like two things basically. So this is the IDX. So here this argument will have like some options plus the file names. So the options we need to delineate those things and then only like sort the remaining ones. So that's why we are doing this basically. And then so the files are in the second part, and the options are in the first part. So we detect that here. And then we just say basically like now if we don't know exactly like how to match this, so here basically like all the arguments are starting with the dash, so that's how we know that they are the options essentially. So now if you don't know, then now we need to just guess. So basically like we set the files and the options, and then we just go through each of the argument and see basically whether that belongs to an option or belongs to a file. So we appropriately like increment one of them. Now once we know that, then now we need to read the lines from the files. So we start reading the file basically, and then if the length of the file itself is equal to 0, then we read it from the standard in if we want, and then otherwise for each of those files basically we see like if the string equal to dash, then we actually like close the file, otherwise we open the file for read only and then set the close to 1, and then here we just start reading line by line until we end up in the file. And then here is where we sort the lines, and then this is like in place sorting. And what we do is we set those the lines essentially, which is this particular array here. Essentially like we do this this command. So let's go through this one by one. We do an eval. There's a list basically which converts the whatever the output into a list. Then we do an L sort, which is a list sort of the options, and then basically we give a range, and here basically like we convert the lines into the list, and then essentially like lines, initial lines is actually like set to nothing, null. So this particular command actually it sorts the lines in place and basically it gives you the whole list as one. I mean all the lines as just one list, and then we then go through the sorted lines and then just print out those lines, print out the line. So this command is fairly simple. It's just a for each, and then we just read the list lines line by line, and then just put each line into the standard out. So this is what we covered last time. Now we will start some new thing basically. I hope like I mean once you start understanding this particular program, you will be okay to actually do the any kind of tickle program. And here I actually like mentioned that basically if you look at the levels, that will give you the good indication as to how this whole sorting program works. So I marked it as like 1 and then 2, then list is L sort is 3, and then we have these options actually like here L range, and then the list, and then the set lines. So as you know, like I mean it's all evaluated from inside one by one. So this is the nested command that gets executed, and then here the range is 0 to 0. Okay. So now we will go to the next module. Let me talk about that. So today we will be taking it to the next level. We will actually review the we will actually go through the TK today actually. So TK stands for toolkit. It's a very concise or very precise term because what TK is about is nothing but just a toolkit for doing graphical user interfaces with tickle commands. So that's what we will be we'll talk about. But before we go there, I want to give you a quick recap of our previous lectures. Actually, we started learning about tickle a couple of weeks ago. We understood that actually tickle has like it's a language that really not a language but mostly for scripting. So it is very easy to use and not a big heavyweight functionalities. And typically tickle is just a set of commands which are separated by new line characters or semicolons, and each command is just words separated by white space. and the Tcl interpreter itself does not put any kind of restriction on this, and it passes pretty much everything to the parser. And typically in the command structure is first word is function and then the others are arguments. Only the functions can apply meaning to the arguments, so that's why like the interpreter does not put any kind of restriction on the commands themselves and then passes everything faithfully to the parser. And then it also allows you with single pass tokenizing and substitution. So all the variables, the commands themselves, they are all like substituted at once. But if you have like next nested command, the parser will send it back to the interpreter, and interpreter may send it back to parser again in a recursive manner. And then we also learned about dollar being the symbol for the variable substitution, and then the square brackets will cause the command substitution. Any kind of quotes prevents any substitution. Actually, like it prevents the word break, but it allows all the substitution. But if you are using a braces, then that braces prevents all the substitution. We also learned about the escape characters, which is backslash to escape specific characters. And the key thing to note from all these things is that Tcl has no grammar. We also learned about procedures and some of the special commands in Tcl for various activities, whether it is file IO, regular IO, or just executing a command. Things like that we learned in the last lecture. So today we are going to shift gears and focus more on TK, which is the toolkit. So what is TK? So TK is a very efficient way to, and mostly like fun way to build user interface or the graphical user interfaces with Tcl. And then it has this three basic structures: the windows, widgets, and processes. We will learn about these things. And then we can create widgets using class commands. And then there are specific widget commands as well. And most of the geometry management is through these two commands called placer and packer. The commands themselves are place and pack. And then we will learn about bindings because the bindings are how we can map a particular button or any kind of graphical interface unit into executable command. And then there are other commands like send, focus, selection, window manager, and graphs. Couple of examples of commands, essentially like show vars is one command and make dialog is the other one. So now let's look at how a TK application is organized. The TK application has a widget hierarchy. It still uses just one Tcl interpreter and one process, but you can have like more than one application in a given process. So what is a widget? So widget is nothing but a window with a particular look and feel, and it is generated by the TK. And widget is again it's a class by itself, and the classes are implemented by TK. The particular classes that gets implemented with TK are frame. So a widget can have a frame, it can have a label, it can have a button, it can have a check button, radio button, menu button, menu, message, entry, text, canvas, scroll bar, scale, list box, and top level. So again, the widgets can be nested for this because you have a top level widget that you can specify. So now let's look at the widget hierarchy. So at the top level, it's specified as just dot. That's the topmost level for a widget, and then under the dot has three things, basically three objects. A list box, so it is denoted as dot list box, and then menu, which has dot menu, and then the scroll, which is dot scroll. So in this case, essentially you can see that basically this is all the top ones, basically, which is the list box, and then here is the menu, and here is the scroll. Those are the three main things essentially. So it's listed out here. So the widget, basically it's this empty box as one, that's the list box. Then you have menu item, and then the scroll bar. So and then under the menu itself, we can have a menu file and a menu help. So you will see like how we can do these things basically. So those are file and help. So this entire thing becomes a menu. So now let's see how it works. So there are three types of windows as you can see here. One is the main window, which is this whole thing which is in red. You can have an internal window which is scroll, it has its own window, as you can see, and then the menu help has its own window when you click and open, and then file will have its own window. Think of this way. Now if you click something and then it opens a dialog, the dialog comes under the main window. So dot dialog, that's what is also called as the top level window. And for this one, actually there is a message which is essentially like this text here, and then yes and no. So those are the only two more additional things for this. Now how do we create widgets? Each widget has a class. It can be a button, it can be a list box, it can be scroll bar, etc. And one class command for each class used to create the instance. So if you want to create a widget called .a, .b, we need to use one of these commands, either a button or a list box or a scroll bar, and then here we say like button space $.a.b, and then what is the text for that button is quit, and then the command is actually exit. And then here is another one, another widget which is a scroll bar, and then it has the name is .x, and then the orient is actually horizontal. So now you have three things that you can use it to define. One is the class name, then the window name itself, and then the configuration options. So each of the class has several configuration options. So here is the class. Here is the configuration option for buttons as a class. So you have active background, active foreground, anchor, background bitmap, border width, command, cursor, disable foreground, font, foreground, height, height background, height light color, height light thickness, image, justify, pad X, pad Y, relieve, state, take focus, text, text variable, underline, width, and wrap length. These are all most of the buttons that are available. The class for the button, I mean the configuration options for buttons. So it's not specified in a command. The options are taken from an options database. Usually it's the resource manager property or just loads it from the xdefaults file. So once you have the button defined, if any kind of configuration option is not specified during the command line, it takes it from the resource manager property or xdefaults file. And then in this one you can also like use set command to set an option, and then we can actually query these options with the option command itself. If it is not in the option database, the default is provided by its class. So title command for each widget is named after the widget, and it's used to reconfigure and manipulate widgets. So here let's see basically. So here we define a button dot a dot b, and then we configure the dot a dot b with the relief as sunken, and then dot a dot b is flash. Then we also define a scroll bar, and we set the width and the height, and then we also get those numbers essentially. So these are all we can try to reconfigure these widget, and then we can also delete a widget when the particular widget is destroyed. It automatically is deleted as well. So the key principle with widget is all states should be readable, modifiable at any time. So the other one is how can I get any option from any widget at any time. So when we give the widget name, so here this is dot my button and configure minus foreground, then it gives you the foreground as foreground and foreground blue. So it gives you the thing. And here if you give just my button configure, then it gives you the all the items in that widget. That is active background is what is active background, what is the active foreground, what is the anchor, what is the background, and then what is the border width and the background, the whole thing basically that you get. Now how do we manage the geometries of these widgets? One key principle is widgets don't control their own position or even sizes. Only the geometry manager can do that, and widgets don't even appear on the screen until it is getting managed by the geometry manager. And then the geometry manager is essentially an algorithm for arranging slave windows relative to the master windows. So here on the right hand side there is a picture showing how it works. So we get the parameters from the applications designer into the geometry manager. We also get the requested size of the slave size from the slave, and then we also know the geometry of the master from looking at the window. Now the geometry manager provides the size and the location for the slave, and then it also like provides the requested size for the master. We talked about the placer as being one of the classes essentially. So here the placer is actually it's very simple, not a very powerful tool, and it is not described in the text essentially. So only thing to notice is basically like each slave buttons or any kind of objects will be placed relative to its master. For example, if you say like we create a button called X within this scope of this window, and we say basically like button dot X, text is X, and then place with respect to dot X basically X coordinate at Y, X coordinate at 0 and Y coordinate at 0. So it puts it at the top of the this window. Now we can move this window to the middle or towards somewhere another place here just by issuing another place command. So again we place the dot X. Now at the X direction it is 1 centimeter, and then relative Y is basically 0.5. So on the Y you just move it by 0.5 so that it's only like related to the previous value, and then on the X direction it's sorry, in the Y direction it's 0.5 here, 0.5 centimeter. On the Y direction it's just 1 centimeter, and then with an anchor as W. So these are some of the coolest things that you can do. Another one is essentially now the relative X is actually 0.5 and relative Y is 0.5, but the height is increased to 2 centimeter. So now we have this kind of thing, and then the anchor is at the center for this words. So in this example actually we place it with the relative Y of relative X of 0, relative Y is 0.5, so that is the center, this way. And then relative height is 0.5 as well, so it adds up those things, and then the relative width is 0.5. So you get a widget looking like this. But in today's design we use what is called a packer or a pack command. This pack is more powerful than the placer. It arranges the groups of slaves together that forms the packing list. The packs slaves around the and it also packs the slaves around the edge of the master's cavity. So the way to place is essentially like you pick the side of the cavity, slice off the parcel for slave, so this is gone, and then optionally grow the slave to fill the parcel. So you can actually increase it this and then fill it up as well. And then finally like save position the slave in the parcel, where to put the position and where to put the slave inside the parcel. Another thing is like how do you choose sites with packer? So in fact with packer it will become much easier, because now you can say like so in this example we have defined 3 buttons: OK, cancel and help, and then we just issue one command to pack everything from left to right. So OK, cancel, and help goes from go to the side left. Sorry, it's not left to right, but it's towards the left. Now we can reconfigure the cancel button. This time we are going to configure the text as cancel command. So basically just one command and it will do it for you. And then the other thing is to place these buttons one on top of each other. For that we just change the option from side left or to the side top. Now we can also put paddings on either side of any command. So here we say, like, I mean, for all the commands we do an left padding X of 2 millimeter and then Y padding distance of 1 millimeter. So it achieves that way, and then we can also like increase or decrease the padding length and padding width. Now in this example, actually you are doing some additional padding using the iPad X and iPad Y, which are the internal padding essentially. So internal padding is 1 millimeter and 2 millimeter, 2 millimeter on X and 1 on Y, and then outside also is 2 millimeter and 1 millimeter. So final output of the command will be something like this, because it needs a bigger wider area. So one other thing is oftentimes we need to fill a button or fill a particular widget with the button. So for that we use this fill command. So as you can see here, when we define without the fill command, you can see that it leaves this white space here because this command is so long. So now with fill X, what happens is basically the each and every button is increased in its size to match the widget itself. So here is another example where we specify the pack menu is top side top. So there is this menu comes up here, and then we also coded a scroll bar. As you can see, it's a tiny scroll bar here, and then we coded a list box essentially, which is here. No, actually this is the menu. So the list box is here. So the menu is here. The top right scroll bar is here, and then this is here list box. So oftentimes what we want is this actually looks very ugly and it's not like really pleasing. So in order to make those kind of changes, we use fill X and fill Y. So here we say, like, so menu side top fill X. So originally like file was here, but since we say fill X, it actually moves to the front of the line. So here is the file, and then this button itself is extended all the way front. So that is fill X, and then the scroll bar we want to fill the Y direction. So we put this thing here so that it's basically it's top to bottom the scroll bar, and then we can have our little list box which is here. So now we come to the expansion. So how do we expand the thing basically? So we increase the parcel size to absorb the extra space in the master. So this is something that we saw already. Like we have these three dot OK, dot cancel, and dot help that we pack towards the left side essentially. Now we say the OK and cancel we need to pack it to the left side, but the OK and cancel, and then the help can itself be pushed to the other side, and then basically like we say that here pack the dot help, the side is left, and then the expand is true. So that way we can actually have some control. But now if you do a expand true filler X, that will fill up all the space with the button itself. So here we can see basically that once we say OK cancel set, the help side left, so that is very similar to this, and then we say dash expand true fill X. So if the X axis is true, then it basically fills out the whole button. So that's the difference between the expand and expand fill. So now if we say like expand equal to true, then it puts those buttons far away. They still look okay. Only thing is like, I mean, there are all these white spaces here and here and here and here. So we can issue the command with expand as one and fill as both. So that means that it's going to do the filling on either side. So here on the same token, basically, like since they are this apart using expand, now the expand is one and then fill is both, so it actually extends on either side. So here is some more packing. So if you want to create like more complex arguments, it's always better to use additional frames. So here is one example. The frame left. So here we call this frame as dot left. And then what does dot then left have? Basically we pack the dot left side towards the side left, and X is 3 millimeter and Y is 3 millimeter. And then we decide to put a frame on the right hand side, a frame called dot right, and then the dot right is essentially like, I mean, we put it at the right, and then with a padding of 3 millimeter and Y of 3 millimeter. And then we also have these radio buttons, which is we are just generating one by one. And then here essentially like it has the variable points, variable size, and then the text. So the size will be taken for packing. So here is one example. So we have like all these machines: PTS 8, PTS 10, PTS 12, PTS 18, and PTS 24. So we can just say basically pack everything in the left side with the top anchored at called W. Then we can have various buttons to check basically. Dot bold is basically like the text is bold and the variable is bold. Dot italic is the text is italic and then variable is italic. And then here check button underline and text underline, variable underline. So for the text basically like in this underline check button has these texts. And then you can also say like dot bold, dot italic, and dot underline in the same pack. So here basically like these are the main formats, and then input is dot right, and then output is anchor W. So today we will also like learn about these connections and probably like stop at that point. I think like we'll continue with bindings in the next class. So the connections essentially like so questions are how to make widgets work together with an application and other widgets. So this is the whole purpose of the tickle. So we put the tickle commands and then it should work there. And the widget actions are tickle commands. For example, the button a.b dash command exit. The button release is kept there, and then every time you press, basically the program just exits. And widgets use tickle commands in order to communicate with each other. So here is an example: scroll bar s defined as a scroll bar. Command is text.yview. Also, the applications themselves use widget commands to communicate between the widgets. So that's pretty much for today. So as a review, what we did was we started looking at TK today, which is the toolkit that goes hand in hand with Tickle. We looked at the main data structure in Tickle in TK, which is nothing but generating widgets. So this is another thing that we saw basically like Tickle is nothing but the whole bunch of widget commands, and then we need to create a widget and using the class command, and then do some geometry management, and then finally bind the user interface to the particular command. And then there are other commands very similar to the class commands: send, focus, selection, window, etc. So this is something that we saw today. Then we also like went into detail about the widget hierarchy as to what different flavors are there. So at the top level, basically it's the dot, and then after the dot, it's after the dot it goes through the various other commands here. Then we also looked at the creating widgets, how to create a widget, and then some of the options for the command. We use some of these options in our program. Then we went into like the widget commands themselves. and finally we started looking at placer and the packer, mainly the packer, which is the most versatile command in TK. So here we looked at the various ways of arranging the widgets using the packer commands, and also like make it more easy to look at. And then finally we looked at the connections and yeah, mainly the connections. So how to make the other Tcl scripts work together as one unit. So there are many ways of doing it. Basically, like they can communicate to one another using Tcl. They can communicate or uses widget commands to communicate with widgets, and then basically like widget actions, how they relate to the Tcl commands. So I think that's pretty much covers this lecture. We will take it up in the next lecture. Thank you.